Well, dear students, there is one question which has been asked in JEE Mains 2018. Lambda n and lambda g are the de Broglie wavelength of electron in nth state and ground state. Lambda n and lambda g are de Broglie wave of electron in hydrogen atom. Lambda and lambda g are the de Broglie wave of nth state and ground state of hydrogen atom. And if electron jumps from some state n to ground state, it emits wavelength lambda n. Then for large value of n, what is lambda n? It is the wavelength of photon emitted when electron jumps from state n to ground state. If here a and b are some constant, then this lambda n is equal to a part, a option. Lambda is equal to a plus b, approximately equal to a plus b into lambda n, b option. Lambda n square is equal to a plus b into lambda n square, C option. This lambda n square is equal to nearly equal to lambda, ये approximately कह रहे equal to सब है, C lambda n equal to a plus b upon lambda n square. These are the options here. Now question is little lengthy here. The question is clear. Lambda n and lambda g are the de Broglie wavelength of electron in nth state and ground state of hydrogen atom. Now if electron jump from n to ground state, the wavelength of photon is lambda n. For large value of n, these are options. Which one is correct? So we know de Broglie wavelength. Lambda is equal to h upon mv, and I have proved mv is equal to root 2mk. K means kind of electron. I hope you remember. Let me prove it by kind of half mv square. You multiply and divide by m here. So m square v square is equal to 2mk, and hence m is equal to this. So lambda comes out to be under root 2mk. For hydrogen atom, if lambda n and lambda g are the de Broglie wave, so lambda n is equal to h upon under root 2mkn. Kn energy of electron in nth orbit. Lambda g h upon under root 2mkg. From here, if we square both the sides, so kn square comes out to be equal, kn comes out to be h square upon 2 lambda n, squaring both sides, lambda n square equal to h square upon 2 lambda kn, and it is kn. Similarly kg, h square upon 2 lambda g. And we know in hydrogen atom kinetic energy is equal to modulus total energy, that is Eg, यानी के modulus Eg, यानी के Eg equal to minus kg and En equal to minus kn. So when electron jumps from higher energy state, so hc upon that lambda, energy of photon emitted when electron jumps from n2 to n1 orbit. Third postulate of Bohr theory. En minus kn or minus Eg or kg minus kg. So it comes out to be kg minus kn. Put these values here. You will get h square upon 2m lambda g minus h square upon 2 lambda n, 2m lambda n. It is hc upon that lambda n. What is lambda n? Wavelength of photon emitted during transition from n to ground state. From here, 1 upon lambda, capital lambda, h कॉमन कैंसिल हो गया, h upon 2mc into 1 upon lambda g minus 1 upon lambda n equal to h upon 2mc lambda g into lambda n LCM. It was square here, तो फिर गलती हो गई था, ये स्क्वायर है यहाँ. तो स्क्वायर है, तो it will be lambda n square minus lambda g square, और lambda is equal to 2mc upon h, और it is lambda g square lambda n square upon lambda n square minus lambda g square. Now you can write it as this lambda n is equal to 2mc upon h into lambda n square common or into lambda g square lambda n square, और ये लिया 1 minus lambda g upon square like this. It is Planck constant here. For large n, for large n, modulus kn is much less than kg. भाई -13.6 होती है काइनेटिक एनर्जी लोअर स्टेट में, तो हायर में कम होगी. सो फ्रॉम इक्वेशन लैम्बडा n इज इक्वल टू hc अपॉन अंडर रूट 2mk. लैम्बडा n मच ग्रेटर देन, हेंस लैम्बडा n much greater than lambda g. So this value come less than 1. So lambda g square upon lambda n square is very much less than 1. So why I am saying here, because I will apply here 2mc. This lambda n square cancel. 2mc lambda g square upon h into 1 minus lambda g square upon lambda n square power minus 1. Now you know binomial expansion 1 plus x to power n. If x less than 1 equal to 1 plus nx. So by using that, lambda comes out to be equal to 2mc lambda g square upon h 1 minus plus lambda g square upon lambda n square. If we open this bracket, please do a good practice into lambda g square plus 2mc lambda g की power 4 upon h lambda n square. Here mass of electron constant lambda g, the wavelength of d wavelength of hydrogen ground state fix. तो ये constant हो गया पूरा. I write a plus this whole thing is another constant. So b upon lambda n square. And therefore I tell you here, last option is correct. This lambda n. This lambda n, what is lambda n? It is the wavelength of photon emitted by electron when it jump from high energy state to ground state. And this is a good question here. You must practice actually. By doing a question we get so many concepts. D Broglie फिर याद आ गया. Total energy of electron, magnitude of total energy of electron is equal to kinetic energy of electron. तो ये सब करने से ही होगा. Now there is another question here. This question was asked in 2013 JEE mains. Now other question. Rydberg constant is 10 to power 7. This is the 10 to the power 7 per meter. Then you are asked here the wave number of last line of Bohr series in hydrogen spectrum. Wave number of Lyman series. Wave number of last line of Bohr series in hydrogen atom. Wave number you know is equal to 1 upon lambda. Wave number, remember, this is a term I think I forgot to tell you while teaching these series. And for Bohr series, 1 upon lambda is equal to r into 1 upon 2 square minus 1 upon n square. For last Bohr series, n is equal to infinity. So 1 upon lambda is equal to r upon 4. 10 to the power 7 upon 4. 0.25 10 to the power 10 to the power 7 per meter. It is the wave number of last line of Bohr series. This question is asked in 2016 NEET. So NEET questions relatively short and simple. 2016. Yes. So please do good practice. I request you to first like the video, share the video. Now one more question here, a good question again. In an electron in ground state, an electron has jumped from excited state and to ground state. The wavelength so emitted. What is the wavelength? Wavelength of photon emitted. Illuminates photosensitive material having work function 2.75 electron volt per function. The stopping potential is 10 volt. Then what is n? तो n इक्वल टू ऑप्शन ए है यहाँ पर 5, B ऑप्शन 20, C ऑप्शन 3 and D option 4. You have to find out this n. Energy of photon equal to E n minus Eg बराबर h nu energy of photon Eg. And we know energy in ground in any state for minus 13.6 upon n square. And in ground state n equal to 1, so minus 13.6. So here minus 13.6 upon n square minus 13.6 is equal to energy of photon, or this is minus 13.6 upon n square plus 13.6 is equal to E. In photoelectric effect, this energy of photon E equal to kinetic energy of electron, photoelectron plus work function matter. So kinetic energy equal to E minus W. K equal to E minus W. So this energy and kinetic energy equal to electron volt. V is the cutoff potential, which is given 10 volt. V is the stopping potential. So minus 13.6 upon n square minus plus 13.6 or minus 2.75. This EV 10 electron volt रहेगी, 10 electron volt direct. If 10 volt, then EV 10 electron volt is equal to minus 13.6 upon n square or plus 13.6 minus 2.75 or 13.6 upon n square equal to 13.6 minus 12.75 ऐड हो जाएगा and you are left here 13.6 minus 12.75, 58.00. So it is 0.85. So n square is equal to 13.6 upon 0.85. It comes out 16 on dividing. You can divide here, but it is 360 upon 85. 13.6. Oh, 13.6, sorry, 0. So it will come over n equal to 4. So option D is correct here. So I have solved in this video 3 good questions. I will be telling you more questions. In one more video I will send you. Please revise the question again and again. Only once reading the question or watching the video is not sufficient. I hope you will be liking my videos. Like the video, share, and ask your friend to subscribe my channel. Thank you.